Dear students, now I hope that you have done all the question of exercise 6A of your exercise of your RS Agarwal books, and I hope that also you have done all the question up to example 23, which we have done earlier. Now we are going need to overtake next question. Question is on the basis on the method of as sum of two determinants. Okay, because I have noted down to you one sum property in which there is given the sum of two terms, and after that we evaluate it in different two determinants. So we are going to apply this property right now. You can see example number 24. On this basis, b plus c a b c plus a plus b c is given to you. This is a question. Now we can make this determinant into two determinant. We can change, we can break about is this determinant into two parts. One part will be of this bca. You will take the first term of this column c1 bca, and column c2 will be as it is, and column c3 will be as it is. And second determinant you can make by the second element, with is after the plus sign, CAA, CAB, and ACA is some SAE, and C3 row SAE. After that, you can see that because you have done a lot of question, and after seeing this question, you can identify what application, what properties we should apply here. Now you can see that we apply here R1 equals to R1 plus R2 plus R3. So we have applied, because after applying this property you will get a plus b plus c here, and a plus b plus c here, and a plus b plus c here. So we are going to apply this property, and after applying this property you will get same R1 going to change in the favor of R1 plus R2 plus R3. So it will be I plus b plus c, a plus b plus c, a plus b plus c, and in the second row it will be as it is c, c, a, and in third row it will be as it is a, b, and c. Now you can see that in this determinant a plus b plus c you can take out the common, and after taking out the common a plus b plus c, because this is a first determinant and this is a second determinant, you can see out, hai na? So because I want to tell you something. If you are going to applying property in one determinant, then automatically it will be apply in the second determinant, because the first determinant is the sum of the two determinants 1 and 1. So if you are going to applying R1 change to R1 plus R2 plus R3 in the first probability, then same probability you have to apply in the second determinant also. So after applying in the second determinant you will get also a plus b plus c, a plus b plus c, a plus b plus c. Now in the first determinant, because this is a first determinant, this is the second part of the determinant, you can take out the common a plus b plus c, and you will get here 1 1 1 c c a and a b c, and here you will get a plus b plus c. Okay, and you will get 1 1 1 a c a b b c. On applying c2 minus c1 and c3 minus c1, you are going to apply this property. We will get how much? C2 में से we are going to subtract C1, तो C2 minus C1, तो you will get here 0, C minus C you will get here 0, and my students, after B minus A you will get here B minus A, and after applying this property C3 minus C1 you will get 1 minus 1 0, A minus C equals to A minus C, and C minus A you C minus A, and here you can take out the common A plus B plus C, then you will get 1 0 0, A C minus A 0, B 0, and C minus B. You have becomes very familiar to do this type of question. Now I'm not doing so explanation, because you have become so familiar. Now you can see that because in the first row there is a 2 zeros, and here also in the first row here is a 2 0, so it will be better to expand this determinant as well as this determinant by R1. So we are going to expand this by R1. Okay, so we have applying we are going to expand this through R1, and after expandation you will get a plus b plus c. We are going to expand this through R1, and after expandation you will get a plus b plus c 1 0 minus. You can see there is no need to elaborate this, because you know very well to expand. You have done a lot of question earlier. So it will be 0 minus b minus a minus c, and plus a plus b plus c. You will get same term. Now a plus b plus c here. This term is of the first determinant expandation and this term is the second determinant expandation. You can see that a plus b plus c also come here and a plus b plus c also come here. So we can take out the common a plus b plus c from entire term. We have did the same. We have taken out the common a plus b plus c from entire expandation. So you will get minus b minus a minus c plus c minus a c minus b. A plus b plus c, and after we have taken the effect of this minus n in this term, so you will get b minus a and a minus c will convert it into c minus a after this minus effect sign, and c minus a c minus b as it is. Now what should we do? You can take out c minus a and c minus a. So we also have taken out the common c minus a from this term. So you will get here b minus a plus c minus b. B minus b will be deducted out. Then you will get c minus a plus b and c minus a, and you will get how much? C minus a ka whole square and a plus b plus c ka whole square. And because c minus a ka whole square, you know very well, c minus a ka whole square and a minus c ka whole square, both are the same thing. There is no different. There is no different. Okay, you know very well. So we can write down c minus a as a minus c ka whole square, and in this manner you will get the answer of this question. Now we are going to do next our question. In my opinion, this question is very good question. Okay, so we are going to this question. You can see one thing. I am yeah, okay. The question is x does not equals to y does not equal to z, and the value of this determinant x, y, z and s square, y square, z square and 1 plus x cube plus y cube 1 plus z cube equals to 0. This is it given the condition. First condition is this and second condition is this. Second condition what is? The value of this determinant is equal to 0. Then you have to solve the value of x, y, z will be minus 1. You have to solve this. The value of the x, y, z will be equals to minus y. And this question is also based on the base of the question of the sum property. So what we can do? We will take this determinant equals to 0. And what should we do? This C3 is the sum of two terms, 1 plus x cube, 1 plus y cube and 1 plus z cube. So now we can convert it into two different determinants in such a manner that first determinant you will get by putting C1 in a same manner x, y, z, and S2 into same manner x square, y square and z square, and C3 will be the first part of C3, means 1 1 1, and second determinant you will make as it is, putting the C1 x, y, z same as put it second C2 x square, y square, z square, and C3 will be the second term of the this determinant, means x cube, y cube and z cube. Now what you can see in this question, x square 1, there is no change in this determinant, but what you can see, you are seeing very well that x is a common from R3 and y is common from R2 and z is common from R3. So you have taken out the x, y, z as a common, and after taking x, y, z as a common, you will get here 1 x and s square, and you will get here 1 y and y square, and here you will get 1 z and z square. Now you can see that this determinant and this determinant are also so much familiar, so much related, so much similar. Similar is a very good word, because these are approximately same, but the place of the columns are changed. Here xyz is a first column, and in this matrix xyz is a second column, and x square, y square, z square is a second column, and here is a third column, and 1 1 1 here is a third column, but in this determinant it is a 1 1 1 column. Now we can make this both determinant same. You can make this determinant same by applying the property. Which one? You can do one more thing. You can interchange C1 and C2 to each other. Okay, you can interchange C1 and C2, but this property, because in a previous question I told you, if you are applying a property in a first determinant, then automatically you should apply, you have to apply in the second determinant also. But if you are going to applying this interchanging property, then you are free to applying this property only in one single determinant. Means I am going to apply this C1 and C2. We are going to interchange C1 and C2. Then there is no need to apply this property in this determinant also. But if you are going to apply the property of such type, R2 going to change in R2 minus R1, or R3 going to change R3 minus R1, or R1 going to change in the way R1 plus R2 plus R3, then this type of property you have to apply in both the determinant. But interchange property you can apply in a single determinant, or hardly you will apply only in a single determinant. There is no need to apply on the both determinant if the question arises of the same or similar determinant. So what should we do? We have to make xyz at the first place and 1 1 1 on the second column. So you know very well, if you are applying the interchanging property, then automatically minus will be there will be change of minus sign change. You know very well this property. Earlier we have also applied this property. Means if we are going to change, or we change the C1 C2 or C3 C2, means you interchange the column, then minus 1 automatically will be come out. Okay, so we are going to here applying the property C2 interchange C1, means you are placing the C2 value at C1 place and C1 value at C2 place, then you will get minus 1 sign on the outside of this determinant. Then your new determinant will be xyz 1 1 1 x square y square and z square. Now after applying this property, you can see that there is also a different. Means what is it different? X square y square z square here is C2 column, but in this determinant x square y square and z square is a third column. Now again you can apply the property of interchanging which one? C3 interchanging C2. So if you are going to applying this property again C3 and C2, then again you have to take minus sign common outside this determinant. So we are going to do the same. You can see in the next step what we did. We did nothing change in the determinant first, but here we have interchanged C2 and C3 each other, then minus 1 will be out common. Then you can see that now this determinant and this determinant have become same determinant. Now what should we do? The question should be around arrive in your mind, because here both determinant are same. So here you can take out the determinant common. Means earlier we don't know that whether we can take out the common of determinant or not, but you can see in this question, in this case when both determinant are same, then same thing means same determinant you can take out the common. You can take the common. So where what we did, we have taken out the common this determinant, and if you will take the determinants as a common, then at that place you get single one. So we have routed the one, and when you take the common from this part, then you will get here x y z. So then your term will be 1 plus x and y z, and it will your common term. Now you can see that 1 1 1 here, so it will be also no, it has been arrived in your mind that we should apply the property here, R2 changing R2 minus R1 and R3 going to change R3 minus R1 way. And after applying this property, you will get x s square 1, and here you will get y minus x and y square minus s square, and y square minus s square you can write down after applying the formula y plus x and y minus x, and at that place you will get down here 0, and here you will get z minus x and z square minus s square, and after applying the formula of z square minus s square you will get z plus and z minus x, and here you will get the 0. Now you can see that what minus x, y minus is the common in R2, and z minus x, z minus is common in row R3. So you have taken out the common y minus n and z minus n, and after taking out the common, you will get here x square and 1, and y minus x here you will get 1, and here will be y plus x and 0, and 1 z plus and 0. Now you can see that here is a 1 1 also, so you can again apply the property of R3 minus R1 making the 0 at that place. So we again applies this property, and your property will be how much? 1 plus x y z y minus x z minus x, and after applying this property of R3 minus R2 you will get x square 1 1 y plus x 0 0 z minus n 0. Now you can see very simply that in C3 row there is a 2 zeros. So what should we do? We should expand this row, this determinant by through C3. So we have applying by the expandation through C3. So you will get how much? 1 plus x, y, z and y minus and z minus will be same as it is, and you will be you will delete it, and you will delete it from this one, and you will get z minus 1 minus 0. So z minus 1 minus 0 you will get here. And earlier it is given that the value of this determinant, because it is the value of given determinant and the value of the determinant is given to 0. But you know that one more condition is given in the question, that what is this? This is that x, y, z. It is given that I can write down here. It is given what x does not equals to z, and if the value of x, y, z and z cannot be same at any condition. Okay, so because it is y minus x, so the value of the y minus x cannot be 0 at all, because y cannot be equal to x at all, and the value of the z minus x cannot be equal to 0, because z and x cannot be equal, and here z minus y cannot be equal to 0, because the value of the z minus y cannot be equal to 0. So we have written here y minus x cannot be 0, z minus x cannot be 0, z minus y cannot be equals to 0, because x does not equals to y does not equals to z, because x does not equals to y does not equals to z. So but the entire value is equals to 0, and this cannot be equals to 0, means if these are not equals to 0, then this term will be equals to 0. So we have wrote down, means 1 plus x, y, z equals to 0, and after taking this in RHS part, you will get x, y, z equals to minus that, and this is the sole part which you have to prove with the condition that x does not equals to y does not equals to z, and the value of determinant is 0, then x, y, z equals to minus 1. Now we are going to do the question number 25. The question is, prove that 1 a square minus bc, 1 b and b square minus ca, and 1 c square minus ab, and this is also on the base of that property of some whose name is the sum property of the determinant. You can see in the third column there is a sum of a square plus minus bc and b square plus minus c and c square plus a minus ab, and you know that in that condition we can change this determinant into different two determinant. In which way? As is, you will write down here c1 as it is, you will write down abc in second column as it is, but in the third column you will write down on the first part of this c3, and you will can put plus sign here, and for the second determinant you will write down 1 1 1 as it is, and abc is as it is, and second term of this determinant you will put as it is, minus bc minus c minus ab at the third place. This property is known very well. I have noted down to you earlier when I go through the property of determinant. I got this earlier, so there is no need to expand you. This is a sum of property. Okay, so we have changed one determinant into two determinant. Now you can see that what because there is a 1 1 1, there is a 1 1 1, so because there is a 1 1 1 and there is a 1 1 1, so it becomes very easy, because a lot of question you have done of the same type. So you can apply the here r3 r2 minus r1 and r3 minus r1. Why? Because we have to make our effort should be to make the maximum 0 with the help of 1 1 1. So we have 0 1 a square, 0 b minus a or b square minus a square, and 0 c minus a and c square minus a square. And here we will get how much? 1 a minus b c, 0 b minus a and c b minus a, and 0 c minus a b minus c minus a. You can do very well after applying this property, and surely you will get this term. Now you can see that if we will apply the formula here, a b square minus a square, then you will get the b plus a and b minus a. So you can take out the common b minus a from r2 and c minus a from the r3, and here you can get also the common b minus a from r2 and c minus a from r3. So we did the same. We have taken out the common b minus a and c minus a. After taking the common b minus a and c minus a from this determinant, you will get 1 1 a square, 0 1 and b plus a, and 0 1 and c minus c plus a. And after taking the common b minus a and c minus a from this determinant, you will get 1 a minus bc, 0 1 c and 0 1 b. Now what you can do that these are not same determinant. In the previous question these determinant are the same, you have tried to common these determinant, but here these determinant are not same, so we cannot take the common. So now we are going to applying r3 minus r2 to make one more zero with the help of this and with the help of this. So you will get how much? You will get here b minus a and c minus a. So you will get here 1 a and a square 0 1 b plus a 0 0 c minus b, and here you will get b minus a c minus a, and 1 a minus b 0 1 c and 0 0 b minus c. Now here in this r1 there is a two zeros, and here this is r1 there is a two zeros, so we can expand this very smoothly by the, if you will expand it through r1. So we are going to expand through r1 here. So when you will applying this to b minus a c minus a, you will get here, and you will delete this and you will delete this, then you will get c minus b minus 0. So you will head down c minus b as it is, because a b minus a plus you have taken out the common from entire term, and you will expand here, you have to delete it, you have to delete it, then you will get over b minus c. And b minus a and c minus a, you can write down c minus b plus b minus c, you can deduct it out by c and bc, you will get the head 0, and the entire value you will get the 0. So you can get the value of 0 of this question. Now I am going to do some examples homework question. Now from exercise 27 I am going to do example number 27 of RS Agarwal book. You will do on self, okay, it is your homework. And from exercise 6b of RS Agarwal book, question number 1 to 10, 1 to 14 you should do, okay, this is your homework. But students, you have know all types of question. We have do approximately two question of each type. Now the time has come to do unsolved question, and if you will do this question from very consciously mind, then I hope that definitely you will get idea what application or what properties we should apply to make this question easy and to solve this question, okay. Because you have your mind have become so prepared, because if you have done exercise 6a and you have done 25 examples, after doing 25 examples, it is my experience that the students had a lot of techniques and a lot of experience to solve out the question in a very easy way. So you can take, you can own assessment, this is your own your self assessment. If you will get the success to solve out the question from 1 to 14, then I hope that you will be able to solve out the 80% question of the determinant. So the students, my blessing is with you. Try to this question, and we will come after with new questions with new mind, okay. So do this question as a homework. Thank you.